Hello everyone. This is Navneet Bhushan from Bangalore, India. I work for a company called Crafitti that we started about 12 years back, and we have been working with various companies on innovation consulting and research also, and we have been major proponents of trees using trees for our work as well as our solving problems for our clients for last decade or more. Uh, the paper that we have submitted is titled Inventing Complex Intelligent Strategic Systems using what we call the ALVIS-SCAN thinking for the sixth wave of innovation. I'll explain this mouthful of uh, adjectives in the presentation, and I hope to explain and make sense of what we're saying also to you. It is a blessing to be able to speak here for TRIZCON 2020. It is definitely a joy to participate in this conference, and specifically in a year which is seeing the pandemic playing a havoc to the world that we have. Also, hats off to Richards and Altshuler Institute for organizing this conference in the way that they are able to do it. There is a blessing in disguise that I am able to participate from India without having to travel. Otherwise, if I had to travel, I would not have participated, or most likely would not have been able to travel, which is what has happened in the previous versions of TRIZCON. So, this is definitely a positive sign. Also the October being month of Altshuler's birthday, so it's a double blessing, I would say, for us to participate and discuss TRIZ in this TRIZCon. So coming to the agenda of my talk and my paper as well as presentation here, let me look at the specific points that we would like to discuss. There are, of course, the world changes continuously, and this is the dynamic world that we are in, and it continuously changes. That is not specifically a new point about the world that we have. However, there is some sort of a change that can be distinguished from the regular run-of-the-mill changes that we are seeing across, and those changes create a bigger impact in some specific particular point of time that we call the waves of innovation, and that also creates what is called the creative destruction. We will explain that the meaning of creative destruction in subsequent slides. Second point is that the wave that we are starting last 3-4 years, and this is becoming very clear now in 2020, is the sixth wave of innovation. I will explain the previous five waves and how what this sixth wave, according to us, is going to be. And then for these, the new wave of innovation, what sort of systems we are going to build or we are going to evolve to, which we call the complex intelligent strategic systems, a specific class of technical systems that is emerging and also going to become more and more intelligent as we go into this wave. This is driven by what we proposed about 7 years back in 2012, Law of Increasing Intelligence of Technical Systems, and also the lines of system intelligence that we have identified last 5 years or so, and which will articulate what is a brilliant system, what is a genius system, what sort of system intelligence gets embedded in these systems, how it will flow ahead is what we're going to look at. Also, a couple of tools of what we should be using or what we have been using, which has evolved through this interaction of systems and functions to articulate or come out with solutions which are in this new wave of innovation that we're talking about, and also the type of thinking that we need to do for the wave that we are getting into, which we call the ALVIS-SCAN thinking. I'll explain that also at the end. So this is the broad agenda. I hope next 30 minutes or so we'll be able to finish this all these topics, and maybe we can have question answers later or even through email or otherwise also. So let us see how it goes. Uh, so the world, as we said about 15 years back in our book on strategic decision making, is driven by these six systems or six complex systems that the world has, which include the social system that we have, geopolitical systems that the world is continuously fighting for or against, also the power system, how the power is shifting from violence, wealth, knowledge, and variety of combination of these things, as Alvin Toffler talked about long back. And technological systems, of course, how various type of technologies are going to impact the world. Then the organization forms, the way we organize ourselves in multiple ways. So it started with hierarchies to pyramids, pyramidal hierarchies to networked hierarchies or networks form that are emerging. And finally, the economic system, how these economic systems are evolving. So when you combine all these things and look at their interplay, the world becomes a very dynamic flux that we have, and that dynamism is reflected in the changes that are observed, also the changes that are impacting in our day-to-day work or even professional work also, for our countries, for cities, for our families, or for us individuals also. So let's go back a little bit about 100 years back or so, to talk to these two gentlemen, Nikolai Kondratev and Joseph Schumpeter. Joseph Schumpeter was an economist and very well-known economist, and he proposed taking the work from Russian economist Nikolai Kondratev's work on long cycles of innovation, which he combined with history and economics to come out with a hypothesis which sort of got verified by the data that he had, which he said that the economic systems changes, and those changes are not happening from trying to be some sort of a stabilizing economic system, but they happen through inherent changes that emerge through technological innovation. So technologies drive innovation, and this, he said, was really the key to the emergence of economic systems or even evolution of economic systems, which were contrary to the established theory of saying that economic systems typically aim for optimizing the existing resources. Whereas Schumpeter picked up Nikolai Kondratev's work and said actually economic system is really about continuous evolution, and he coined the term creative destruction in his on capitalism, socialism, and democracy, which he says that this process of creative destruction, it is a continuous process of industrial mutation, which continuously revolutionizes the economic structures from within. So it is not from outside some influence comes, and through this incessant revolution that is happening inside the economic system, it destroys the existing system, but replaces it with a new economic system. So that the new economic system becomes the new normal, as we are calling now. And in fact, what we are seeing is last 5 years or so, we actually believe that we are seeing a new creative destruction. I will explain this in the next slide. So we have these, when they studied these waves of technological innovation that they observed in history, and when economic system of production changed through because of the new technological introductions, they found that the first wave was more driven by water power, textile, and iron in mid 18th century, and which gave way to second wave through steam, rail, and steel. And the third wave that started from 1900 onwards was more driven by electricity, Then, of course, the industrial combustion engine, which still continues to be the key driving force for the economy. If you look at, of course, it is changing now because of a new type of engines that are emerging. The fourth wave of innovation started after Second World War, which says that it was driven by electronics and aviation, and of course petrochemicals that were also there. So these four waves were really the traditional waves of innovation which used energy, matter, and the physical world, if you may. Somewhere around mid 80s, a new information a new type of resource started emerging, which was based on information, and that information became digital networks, software, and new media from 1990 till 2020 is the fifth wave of innovation that we actually are going through right now. However, it is going to give way to a new wave of innovation for 2020 and onwards, and that we call the sixth wave of innovation. And this sixth wave of innovation, as per our analysis and understanding, will be driven by things getting networked, autonomous, nano, and hypersonic, and when it will also be driven by a new computing which is based on algorithmic intelligence, and in future which is emerging in the next 5 to 10 years on quantum computing, which if you combination of these technologies is going to give us new ways to synthesize biology, energy, and reality. So if you combine all these technological pieces, your sixth wave of innovation is going to give a new method of producing economic value, which is different from the previous five ways. Of course, it uses all the previous five ways also, waves of innovation technologies also, but it also creates new technological elements which makes our systems much more much better, as well as more capable of doing some things which the previous systems are not able to do or able to do efficiently. Now, before we come to the further discussion on this, we'll just look at what exactly happens in creative destruction. When the fourth wave of innovation companies were, saw that fifth wave of innovation in 85 to 95 to that decade, they said that this is we need to do some business process re-engineering or some newer quality processes. But what they missed out was that the new waves of innovation or the new companies that were taking new economic value were driven by a new fundamental resource, which was information. And that information also was captured in the method of processing that information through set of instructions that were given to machines, which were basically algorithms. So if you look at those companies which were generated last 30 years or so, which is the fifth wave of innovation, we find Google, eBay, Amazon, or Facebook, or even Uber. All these companies are nothing but algorithms, basically algorithmic platforms, so to say, and that is an interesting resource, which was very different than the previous four waves of innovation resources that people were using to create economic value. So what we are saying here is that the fifth wave of innovation was driven more by software, and because it has a new type of resource, it was very difficult for people or the companies which were in the fourth or the previous waves of innovation to adapt, or in fact to look at that new resource in terms of using it for technological benefits or economic value, if you may. Now, the sixth wave of innovation that is starting, we believe things becoming nano, networked, autonomous, and hypersonic are going to create, or using algorithmic intelligence, are going to help us to synthesize newer type of biology, energy, and reality, and newer type of realities, which will lead us to create systems which has AI or artificial intelligence and also some sort of mind of their own for next 15 years or so, and maybe sometime around 2030, once the quantum algorithmic intelligence comes into picture, we will be able to understand and make matter itself more intelligent, which will lead to a newer type of reality, a newer type of world, a newer type of economic value that we talk about. So this creative destruction that we are going through, most likely will continue for next 5 to 10 years, and also give way to a newer type of technologies that are going to drive the economic. Let us step back a little bit further down. So, what is happening to humanity is, as we understand the fundamentals, which is space-time. For example, when we understood space-time, we started doing agriculture, crops, how they move, how they change because of the change of seasons, and a new era of civilization emerges when we understand these fundamentals, right? So space-time gave way to agriculture, energy better gave way to industrial revolution. When we understood data and information, it gave to information technology, and also when we are understanding life per se, we are able to control certain life forms and also get into this biotechnology type of era. And maybe in future, as we understand how the thought and mind works, how it can be studied, and also uh, some sort of mechanization of that thinking can be achieved, we will give rise to era of mind, if you may. Okay, so this we call the Stamil CTCP model, which is basically looking at the fundamentals that are known: space, time, energy, matter, information, life, and also mind, how they interact to create the changes that we are seeing across the world. So the question is, can we invent machines with their own minds? Is where the era of mind starts asking these questions. Okay. So next point is that since every time when these creative destruction starts or comes into picture, there has to be an inventive transformation of what we're doing. It can happen through newer type of companies or existing companies inventing itself themselves to transform in the creative destruction. Okay, so how do we invent systems that are needed in the newer creative destruction or the sixth wave of innovation that we articulated? That is the key question that we need to articulate, or we need to understand. So this is the background. So getting this view of what we discussed, let us look at uh, where the classical definitions of the tools and the knowledge that we have plays out in the sixth wave of innovation. So as we know, system, function, and technical systems are fundamental to TRIZ also, and other tools, other methods also that we have, specifically engineering problem solving. We are very this fundamental definition of system as a set of elements that interact together to perform a function, which is some sort of a whole that is created, the holistic view that is created. That is what the system is. A black box model of the system typically is that it transforms or it reorganizes energy, matter, information in space time, and that reorganization results in a certain function to be achieved when it interacts with the object on which it is working. So the function model from TIZ says that tool typically interacts with the object, and that leads to a function being achieved in some form, in the form that we want to achieve. Typically, a function also, the system function interaction requires a understanding of the operating principle of the system. The operating principle is the science behind the system's existence. And for example, if you want to brush your teeth, you need to understand that this brushing happens, why this particular tool works, because of the friction. Friction helps us to clean teeth by uh, using slightly abrasive bristles to remove the plaque or the dirt on the teeth, and it becomes cleaner, so to say. Okay. So the function, however, this is not the only way that you can clean teeth. You have other ways known to you to clean teeth. So that is where the operating principle drives the structure of the system and the type of system that is going to be used for achieving the function, right? So this is where the interaction between system function and the operating principle comes into picture, and that is where TRIZ scores very nicely by articulating these interactions, so to say. Systems view of science, as we discussed by some times back, some years back, in 1983, we had one person in India who wrote this very interesting book called Fountainheads of Science, and he proposed a systems view of science, where he looked at various levels at which the structures or the knowledge that we have about science it can be organized. And he said actually that there are 5 levels at which you have this view, starting from operand set and in various transport chains and information. And each level, if you see, actually is a result of the combination of two levels, two elements of the previous level, and that is how the pyramid evolves. So it has a deterministic phase as well as a what he calls a statistical phase also. So if you look at this, is a very interesting articulation of a system view of science. Similarly, many other people, many other scholars have proposed various organization and taxonomies of systems in the past. So looking at these information that we have organized a framework for what we call the Crafitti system problem framework, which has 9 dimensions of formulation: system type, system function or process type, main operand type of the system, what is the level at which we are talking about when we are looking at a specific system, whether it's technical, operational, strategic, or policy level systems. Then system intelligence is where we have included our law of increasing intelligence of technical systems, unguided, guided, smart, brilliant, genius, transhuman, and global intelligence, as we talked about in the previous slides also. Then the system engineering body of knowledge report that came in May 2020 talks about system context as whether it's a product system or a service system or enterprise system or system of systems. Similarly, various other aspects are there in this framework. So we have these 9 dimensions of system formulation or the framework that we have. And this helps us to understand the context in which the system has been evolving. And using this framework, we are now able to sort of see maybe we should focus on these systems which are intelligent, strategic systems, and also complex, and look at inventive problems that we are going to uh, focus on in generating or creating these complex intelligent strategic systems. So how do we invent those complex intelligent strategic systems is the question that we are trying to answer. So in this context, before we come to the answer, we need to look at what do we mean by complex systems, what do we mean by strategic systems, and also intelligent systems that we have in the literature. Okay. Complex systems, as you may know, have many parts and interactions, but the holistic view or the holistic behavior that emerges of the complex systems cannot be traced back to the individual properties of the constituent parts of the complex system. And that is where the beauty of complexity lies, because the emergence of uh, some new behavior patterns, which when you design using the components of the system, when you have designed the system or when the system was built or was evolving, was never clearly articulated or understood. So a new set of properties that emerge through interactions, and by the very fact that systems, subsystems or the elements interact with each other through certain processes, is the value of complex systems. They exhibit various types of properties, and definitely the reductionistic approaches of classical science are insufficient to explain these behaviors and also explain the model of these complex systems. That is why we have science of complexity per se emerging for last 30-40 years or so. Strategic information systems, specifically the strategic level of these information systems, collect, collate, process, and enhance information. These are those systems that are relevant. They collect information and also process information which is relevant to the operations and processes that may be needed in future in that particular system. So this is where interestingly the may be needed in future. That means upfront when you are designing these, you do not know what will be needed. So you need to have a capability to understand the information that you collected in the technical system and use that information or use that understanding to create uh, some changes in the processes or the operations that the system is performing to take care of the changes or the changing scenarios that will emerge in future. So complex strategic systems are definitely a newer type of systems that have emerged, and because of the interplay of information as well as the complexity in terms of the interaction complexity that we have seen in the way we have built the systems. So suddenly the previous waves of innovation methods that we have used, fourth wave, third or second wave, or early even the fifth wave of innovation methods that are used to design those systems will not be sufficient. And this becomes very clear when we discuss what we call the intelligent systems. So as we said, intelligent systems we defined in 2012 as in our paper in Law of Increasing Intelligence Technical Systems. This was a paper published at the Altshuler Institute also. It is available on their website if you see our 2012 paper. And it says that we proposed a new law which says that uh, the systems that were dumb or unguided became guided, and then they became smart, they become brilliant, then they will become genius and transhuman systems. And maybe interestingly, this was validated by this 2019 report by WIPO, which was published last year, which says that many observers think, or according to them, the current AI booms began 7 years back. If you look at 7 years, it's 2012. If it followed a series of ups and downs, often referred to as AI summers and winters, and this is an interesting observation, and it verifies our work that was published in 2012, saying that the changes or the evolution of technical systems will follow by be uh, emerging by adding more and more intelligence to the technical systems. So this is where a very interesting verification of the thought comes into picture. So the key message really is that using TRIZ can give us a method of thinking and also gives us through this analysis that TRIZ type thinking and analysis can help us to discover new laws of system evolution, and that I think is the key message that we have. So this also is from the same paper, the evolution of system intelligence. As we said, it maps to the fundamentals that we talked about: space-time, energy, matter, information, mind, and how these systems becoming from smart to brilliant to genius will use these resources and also evolve towards potentially global intelligence sometime in maybe after 2050 also. So coming to the invention and method of inventing, uh, we know that what is the invention? It has to be a new solution to a technical problem. It should have an inventive step as per European law, or a non-obviousness as per US patent law, and also it should be a technical solution. it should usually solve a problem in the system that it is targeting. But this process of doing invention has been pretty inefficient and time consuming, and that is where Altshuler's work comes into picture, where he says that our method of inventing, which is trial and error, needs to become more structured, more systematic, and should follow known solutioning approaches so that we lead to the inventions quickly rather than trying to do this inefficient trial and error method. Okay. So when we look at these problems, also TRIZ classifies routine, non-routine, inventive problems and paradoxes, and also we have a new class of problems called the wicked problems. However, we have also found that why these problems occur is because we are trying to fulfill certain needs and also trying to capture some opportunities that are emerging in a dynamic world that we have. So we call it this triad as the problems, opportunities, needs, or the pawns. So we need to invent to take care of these problems, opportunities, needs is what we are trying to say here. Okay. So coming to the function analysis in the classical TRIZ way, we said that, for example, the toothbrush example, where the cleaning function has to be achieved using the bristles which is there on the toothbrush. The objective, of course, is to the teeth, and the action is brushing those teeth, and the operating principle, which is the science, is the friction. Because of the friction, we are able to solve this particular problem of cleaning or achieve this function of cleaning through this. So this is the action matrix that can be looked at from the classical TRIZ. It typically looks at two dimensions. X1 is the useful action and the Y axis is the harmful action. And once you fill up this table, which absent, inadequate, adequate, absent, present values, you will be able to see what are the conditions under which this action adds to newer harmful functions or it doesn't achieve the useful functions that we are aiming at. So aim is to maximize the useful actions and minimize the harmful actions typically through the structure, through structuring the system in such a way that it achieves the uh, useful action that the function requires on the object. If you expand this function analysis, you can look at this, the x and y axis can be expanded, and you can sort of look at fine-grained understanding of the existing system and potential problems in the uh, inadequate, excessive useful actions or harmful actions also. So this is our standard method, is slightly expanded also through this function analysis table that we have created. Now the solutions are to the structuring are typically into three buckets we can look at. We will come out with either with a new system or a new operating principle to achieve that function, which will again lead to newer systems, or we would like to change the existing system hierarchy in such a way that the problems that were identified, the harmful actions that were visible, or the inadequacy of the useful action that was visible in the function analysis can be minimized, right? That can be harmful actions can be minimized and the useful action can be maximized. So this is the typical way. The question really is, how do I change the system hierarchy in such a way that it enhances the useful actions and also minimizes the harmful actions in the system. So this is the classical TRIZ, but with some anatomic changes that we proposed in our previous work that was also published at TRIZ Journal, which is basically how do we invent strong. So changing the system hierarchy is one method, besides of course looking at newer alternative operating principles or systems for the strong inventions. Right? So some classical to questions to classical TRIZ or the fourth wave of innovation questions. So can we have systems that perform the same function but using multiple operating principles? So now here is our interesting challenge. How do we resolve this particular problem of the toothbrush having ability to do friction-based cleaning, also using ultrasound waves, and also using ionic action for the same cleaning teeth function, but achieving through different operating principles. So this system that we're talking about should have these three capabilities or these three operating principles, which the classical TRIZ doesn't really address actually. So because it was not there. Now how do we achieve this? So can we have the systems that will sense which operating principle is needed when? Thirdly, can we have systems that will adapt themselves, its own internal structure to deliver the functions but with appropriate operating principle? Now here the value of information comes into picture, and if this tool that we have talked about has memory, has sensors, and also computing capability, then perhaps these three questions can be answered. So if you have this tool, which is a toothbrush or teeth cleaning system, if you may, it can have a memory, it should have a sensor, it should have ability to process that information in such a way that it can adapt itself and make an appropriate choice of the operating principles at the runtime based on the teeth characteristics and the context in which it finds the teeth to deliver that specific function through the specific operating principle, whether through ultrasound waves or through that brushing exercise, brushing through bristles, or through some sort of ionic action on that. So this is where a new type of systems will emerge, which will be adaptable, which will be strategic, also which will be complex, definitely complex than the existing toothbrush, and also they will utilize the functions that we talked about, which are not necessarily the function of cleaning alone, but it also takes care of the information and use that data and information in a strategic manner. So that is the key value of the sixth wave of innovation, and using these newer type of systems that will emerge. We call them this particular type of system when they have multiple operating principles that are combined in the functioning of the system itself. We call it multi-operating principle systems, and that I think is the key future where multiple operating principles will be embedded and the switching to the specific operating principle will happen at the runtime, and that will be taken through the strategic information that is continuously captured, collated, analyzed, and computed. Relevant actions are computed to take care of in the future whenever that future arises for the system. So black box model of the system, system with a mind here is, of course, we now have system matter, energy matter system, information in space time, but it also has internal structure, energy and information management control, and to represent information and generate new knowledge. And that I think is the key shift that has happened, that will be happening and also is already happening in the system that we are building now. So the key difference, as we said, the classical model of a function gets changed to a model where the tool actually has memory, sensor computing, and its ability to make choices at the runtime emerges, and maybe smart to brilliant into genius systems will start emerging. Now, once we did this law of increasing intelligence of technical systems, we also looked at what are the key functions of the mind or the brain, if you may, and we found some seven key capabilities that the brain is involved in, which we call the lines of increasing intelligence or the mind functions in the under the law of increasing intelligence technical systems. We have this towards perfect sensing. So we have a line of sensing, detecting, and recognizing. Then we have towards wisdom, which is line of processing information or data, computing, and knowing, which we call the lines of towards wisdom of machines. Then we have learning towards perfect learning, line of learning, and then the decision making, which is towards perfect choices and decisions, which is line of choice selection, and towards perfect creation, which is more of ideation type of line, which is line of concepts creation, which is the fifth line. And then we also found that mind also is intuitive. Now, where does this intuition emerges? So maybe towards perfect intuition is what we should be aiming for. This, of course, is more maybe in distinct future when we understand how intuition works in the mind. And of course, the seventh line is already happening, but it will become more and more required in the future when we are going to work with lot of intelligent machines, collaborate with multiple intelligent machines in our ecosystem, in our professional life, or in our homes also, which we call the towards perfect collaboration lines of machine, society, and culture, which will emerge. So, corresponding to each of these lines, we also have certain stages of certain specific steps towards these lines. And so sense of detecting and recognizing starts with recognizing or sensing a single system parameter which goes to multiple system parameters, and then system parameters interactions we can sense and detect and recognize, and then maybe system of systems parameters and system parameters interactions. So towards these various stages on these lines, we can map the existing system and see how do we invent the next system which will move from the previous stage to the next stage on each of these lines. For example, when we look at collaboration, how the how microorganisms, for example, collaborate with each other. Can our robots be like that? Or how do insects collaborate? How do fishes collaborate? How do birds collaborate to perform a particular function? So this way we can actually see variety of emergence of various type of combinations of these intelligent machines and systems which will work together autonomously and also runtime evolve towards solving and creating newer type of solution. So these seven lines of increasing algorithmic intelligence we already have identified and utilized in our work, and it has been a pretty nice results we have seen in the. So second tool that we have used is in the specifically the MOPS scenario, multi-operating principle systems, where the system function interaction, how the system and function interacts through these operating principles. We actually identified certain parameters of system that will make the unguided system to a guided system, to a guided system to a smart system, then to a brilliant systems. These parameters are already there in the inventions that we have analyzed or the patents that we have analyzed. So for each of these parameters, what we are saying is that system, if it has to become a smart system, it should have these parameters, these system capabilities, so to say, in the existing system, or in its own structure that it has, or it should be aided by other systems which can be utilized at the runtime. So typically a distributed system or a cloud-based system can help them to become intelligent or can be utilized in some way. So the distributed ability of the newer systems that we are coming out, specifically the cloud-based computing that has changed the world for last 10, 15 years or so. And of course, the newer, when the cloud itself is becoming more edge computing type of a scenario, where I think the newer type of systems will have more intelligence embedded at the runtime, at the point of action, and maybe they will be able to learn and utilize the lines of algorithmic intelligence much better. However, the system function interaction tool gives you a very clear way in which multiple operating principle systems can be orchestrated through an architecture that definitely will be a multi-operating principle system. So the technical system of sixth wave of innovation, for example, in the toothbrush scenario that we talked about, right? So the value of doing this, okay, so the question typically comes, it is a simple toothbrush that was serving my purpose. Why do I need to move to such a complex one, which is such a costly system? what is the point about doing such shifts? So the key value here is that over a period of time, every interaction that is happening, whenever the two physical systems interact, there is data that also gets lost unless it is captured. That data of daily interaction of your teeth getting interacted with your toothbrush, there is a information that is not captured at all. And that information, if you can capture and utilize for the improvement and also diagnosis of your the health of the teeth and the gums or your oral health, it can help you to mitigate the potential dangers in future of going to dentists, and also the number of root canal surgeries that you may have to do throughout your life may be minimized if you use this sort of system. So that is the key message here, that the hidden data in the interaction of the physical systems that we have is a huge value that is, since we are not able to capture at the runtime, we are not utilizing it, but it has a huge value if we can capture and analyze and use it for the future planning or future actions, so to say. So this is where the strategic part comes into picture. So the 2045 Genius tooth cleaning system will be much better than your existing dentist that you have. It will be able to help the dentist also in future. That is where we are aiming at. Okay. So architectures of these systems, if you see, when it brilliant systems becomes genius systems in future, that time ideas and inventions will happen by the genius systems. But from shifting from smart to brilliant systems, decisions and learning by the systems themselves, which is where the autonomous systems emerges, is the key shift that we are going to see, which we call the intelligence of things. That is where we are aiming at. And but of course, as we say that whenever the evolution of technology happens, there are newer problems to be solved, and we have these couple of problems that we need to solve. Is how does these cobots, the collaborative bots and humans, going to work together? Can they be designed, for example, from nature's algorithms of how ants works, or how honeybees works, or termites, or birds flocks work together, or locusts? So here this interesting book by Peter Miller says about the smart swarm principles. From what he says, that there are two specific points here: the self-organization and the diversity of knowledge that gets tapped into these principles, which he calls the smart swarm principles. So how do we make these smart swarms of these intelligent machines that we are going to have? Also, how do we work with these intelligent machines? How does humans and co-bots, collaborative bots, work together in smart swarms? Is the key question that we need to solve. Second type of problems is the algorithmic intelligence needs. Ultra large scale systems. How do we scale these systems? Intelligence of machines, of course, we talked about. And finally, how do we utilize the network science as a system analytical as well as network science based principles to be captured in the system's mind, if you may, or the system's intelligence, is the key questions that we need to answer, because networks need to evolve, and that network based behavior need to be understood to be incorporated in the intelligence of the machines that we are talking about. So finally, if you really look at this solutioning of these problems, we need to transform our thinking, also enhance our thinking to a newer thinking dimensions that are emerging, which we call the creative transformation, and typically towards what we propose the innovation system. Here we have this our framework which we call the explore, ideate, empower ideas. What I want to focus is on the ALVIS-SCAN thinking, which is a short form for analytical, logical, value, inventive, and strategic thinking. That was our framework. But for the sixth wave of innovation, we are saying that scale thinking, computational thinking, algorithmic thinking, and network thinking needs to be incorporated in our ability to invent and our focus on inventing. So this will require some work to be done, but we have some initial points about what exactly these systems or these thinking dimensions need to be. Of course, the overall framework requires us to do this find, design, evolve, adapt. There are three key stages. Find, of course, is the see, observe, understand, live. There is various tools from TRIZ and other methodologies also which can be utilized or combined to perform these functions. But this is the key of solutioning, where we need to design the needed change. Here, the analytical thinking, logical thinking, value thinking, inventive thinking, system thinking is already part of our repertoire, and most of us will know about these thinking tools and dimensions also in some form or other, and we may be using it in some form. However, what we are seeing now is the scale thinking. How do we use the laws of scaling and blitz scaling, the rapid scaling that we have seen in the IT or the platform based world that we have, and the N by N markets that we're talking about, that the businesses are trying to design? Now, how do we scale? How do we use those laws of scaling to scale our initial platforms? Finally, secondly, the computational thinking, data-driven understanding of the world around us, because we have so many sensors, but how do we understand that sensor and their data, and how does the data combine together to give us this computational thinking is the key question that we need to answer and we need to incorporate in our solutions. Third is how do we reduce these processes to set of instructions for machine to implement those procedures, which we call the algorithmic thinking, and this requires a flow from data-driven computational thinking to designing the algorithm which are efficient, which are usable, and also which are optimized to the specific machines and the context in which the machines are. So along with this, the fourth dimension, which is network thinking, which is of course maximizing value through network resonance. How does these nodes of various network entities, how does they resonate with each other? Because their intelligence and their other capabilities is going to be very different. So there may be an impedance mismatch between their interaction capabilities. So when they are going to interact, how do they maximize the resonance so that we can solve the problems that we are talking about for the sixth wave of innovation. So sixth wave of innovation thinking skills are scale thinking, computational thinking, algorithmic thinking, and network thinking. That these four thinking dimensions need to work with the Alvis thinking that we talked about in the past. This is where once you have the solution, then you need to communicate, relate, allow, follow up, and turn around. That is our standard way in which you propose your solutions to the world at large so that they can utilize these solutions in their context in the way they want. Finally, we have this law of increasing intelligence of technical systems workbook that we typically suggest should be utilized. But after going through the theory of these laws of increasing intelligence, when we have to solve problems, and of course, what type of problems? The paths to innovation, we have these five paths: imagine, transform, solve, fulfill a hidden customer need, or utilize foresight. So foresight is where law of increasing intelligence type of foresight comes to picture. Corresponding to each of these, we have five different type of projects that we utilized in our work. And of course, we have this idea journal that we can share. If you send me a email, I can send it by email, or I can share it with Alshul again. So it's a simple document which we suggest that all of us can maintain this idea journal, and which help you to articulate your ideas in just 150 words, each idea. And over a period of time, maybe you can collect all these ideas and maybe create your own idea repository which can be well developed into invention. So what we discussed in this presentation is that in the dynamic world that we have, there are waves of innovation, and last 4 or 5 years we are going through a new creative destruction, which will giving way to sixth wave of innovation, which is driven by complex intelligence strategy systems, and which utilizes which we call the increasing intelligence of technical systems. And also you can also develop your own intelligence systems of the future using lines of system intelligence, and make your smart systems brilliant and maybe genius. Also, we have identified certain system function interaction tool that can be utilized to understand how what system parameters should be utilized for the shift from the smart to brilliant systems. And finally, holistically, we need to combine the analytical, logical, value, inventive system thinking with the sixth wave of innovation thinking dimensions, which is we call the scale, computational, algorithmic, and network thinking. And this, I think, is the key question that we should be answering. How do we utilize newer thinking forms or newer thinking dimensions to create brilliant and genius systems for the future? So I thank you all for listening to this talk, and also to Richard and Alschuler Institute for providing us this forum, and also conducting this 2020 TRIZCON. And I thank you very much for this patient listening. I hope I have not exceeded time. Thank you.